recording, and I will share my screen. All right. Can you all see my screen?
Yes.
Okay, great. I'll remind everyone of our antitrust policy and that all of the calls will be recorded and they will be available up on the TAC Wiki along with all of the presentations and minutes from every meeting. Here are all the useful links. If you can't remember how to get to one of these links, whoops, sorry. You go, just remember those first 8 characters, LFAI data. That will take you to all of the other links that you can use to find all the information available. So we'll start by checking to make sure that we're achieving quorum. We'll keep watching for that. Looks like we're getting closer. And I think we'll hold off on minutes just till we get everybody going here. And we'll move on into our proposal. And Romeo is our presenter today. I do want to remind everyone, if you are a voting member, it helps us a lot count for quorum if you can change your Zoom display name to represent which company or project you are voting for. So here's an example, and that's easy to do in Zoom. Just click on your ID and you can change that information pretty easily. I see many of you have done that already. Thank you for doing that. When you do provide a vote and you're choosing to submit a motion, please state your name and the company or project that you're representing so we can record that for the minutes. And this is the latest updated member representative list. If you haven't given us a substitute for you and you can send that to me, we will be sure to record that in here and include them on the meeting invite. All right, we'll move on from the minutes and we'll move over to Romeo. Romeo, would you like to present your screen?
Yes. Let's actually get this going. Okay, can you see my screen?
Yes, we can.
Perfect. Okay, so some of you might remember the last pitch I gave for Elira, and again, thanks for accepting that as a Sandbox project. So this claim project is related to Elira, but it has a lot of different aspects. That's why I want to push it as a separate project. And I think you will understand that a little better later. So let's dive back into Elira for a second, or especially in Jupyter Lab at the moment. So if we now go to Jupyter Lab and we will have a look at this claimed Git repository, you will see a folder called component library. And this was the initial idea when we started with Elira, that you can drag and drop notebooks and Python scripts and so on to the canvas. And then later on you click on play, and then it will be compiled and pushed to the appropriate runtime, locally, Kubeflow, Airflow, and whatever it's supported in Elira. So in Elira, we have now 4 runtimes supported. And later on, we then found out that this is a nice thing for, let's say, POC style projects. But if you want to go to production, you want to have native components for the target runtime. And that's why we came up with the idea of Claimed. So Claimed stands for the Component Library for AI, Machine Learning, ETL, and Data Science, just to cover all the buzzwords, no? And it's a set of Jupyter notebooks plus a specification how to transform those Jupyter notebooks, and also Python scripts and R scripts and shell scripts. And we are also targeting Julia in the near future. A set of simple rules which a data scientist can follow to have the claimed system take it and create a component for the target runtime. And I will show you that in a minute, a little more clear. So this is the, let's say, ordinary notebook or script-based pipeline. And I just show you the example ones. We automatically created Kubeflow pipeline components, because then you can use any Kubeflow pipeline tool to use them. In this case, Elira supports it as well. So we are using here Elira only as a client to those components. So those components here, they are on the local file system, but we can also export them to a registry or asset registry, like for example, LFAI ML Exchange or similar, and pull them in here. So that allows you to create a fully open source, scalable, no code, low code environment for drag and drop data and AI pipelines. No, so you might have seen those tools in the commercial space and also in the non-commercial space. I will show you some examples later and how it compares to it. And what you can do then is you can just click on play and then you can fire it away, and then it will eventually end up in Kubeflow. We have just one little thing in the latest version in the master branch that we have an error here. Otherwise, I could have shown you the whole pipeline running. So this is a very simple example. It pulls some data from somewhere and applies some transformation, and the result goes up to Cloud Object Store. The whole pipeline obviously can also include model training and model assessment, including trusted AI, library applications, and so on. You see also here a feature of the runtime, which we are making use of, that already run components won't execute again on the second if nothing has changed. So that saves a lot of time during development and also in production. But now let's just move over to the slides. So let me just go to full screen here. So I'm here introducing the claimed framework, the component library for AI, machine learning, ETL, and data science. So this is basically what you have seen. So claimed is a runtime and programming language agnostic data and AI component framework, abstracting away all complexity for advanced MLOps and trusted AI. So the idea is that a data scientist who is familiar with his tooling, so his programming languages and libraries, doesn't need to care about the ML ops and trusted AI aspects of productionizing such a pipeline, including Docker, Kubernetes, Knative, Kubeflow, Airflow, YAML files, and so on, and Docker files. So it's much more easy for data scientists to just get the things going. So the problem we are trying to solve is that we base every component on a simple asset like a Jupyter notebook or a script, and there is no need to know something about those underlying technologies. So where does it fit in the ecosystem? So the components have already incorporated some LFAI projects like AIX360, ART, and AIF360. Also Kserve and Onyx. Elira acts as one consumer of the components, and ML Exchange as one component repository. And then C3, which is part of Claimed, is the Claimed component compiler, which currently takes the already existing 70 components which we have in the repository and creates components for Kubeflow. We have POCs and concepts for other runtime engines like Airflow and Slurm, SnakeMake, Galaxy, and NiFi. And also in the LFI ecosystem, we identified Flight, Kidro, and Ludwig, which could be targeted as well. And again, here Kidro looks the most promising. To have a little overview on the ecosystem, so we have two tables here. One is showing us some aspects of the execution engines. And the reason why we targeted Kubeflow first is because it gives us the most functionality, but that's obviously not something we want to decide. We want the community to decide what execution engine they want to use. And Airflow is very promising and just overtaking Kubeflow in some areas. And then the other things, we have Slurm and SnakeMake and similar, which is very, very foundational in existing year-long deployments. That's also a reason we want to support those. And then from the, let's say, open source, no-code, low-code tooling, there is NiFi, Node-RED, NIME, and Galaxy. And we also found out that Elira for us supports the most. But again, we want to be agnostic of the consumer IDE or consumer way of incorporating components into a pipeline. That's why we also want to support others. This is a very nice example. So we have, let's say, a production user already of the library, which is a hospital here in Basel. And obviously, that's not a true image from the client. It's open data, but we ran the same algorithm on this open data set. And then we applied from AIX, the Lime algorithm, to just highlight the areas of the image where the algorithm is looking at. And this can be done just by drag and drop now. So you don't need any programming skills at all if you don't want to use them to create such a heat map from your trained model. And then we found out that this algorithm is actually mostly looking at bones. And then we went to a doctor, and then he said, yeah, actually that area top right, you can clearly distinguish the gender. So that's a very interesting use case, no? Because we just thought, why is the algorithm performing well, but still looking at the wrong areas of the image? And we just noticed that the target variable is correlated with the gender, and that's a super interesting use case now. Okay, so this is the overall architecture for the KFP components creation use case. So on the left-hand side, you have the claimed source code. So the data scientists, they create their reusable components and publish them and share them with the community. So those are opinionated components, coarse-grained, for example, like reading data from a database and publishing something on Object Store, training a machine learning model using MobileNet V2 or something like that. So very coarse-grained, opinionated. Some people had thought about it and created something reusable, but still the source code is available. No, it's a double click and you are brought to the source code if you want to double check how it's implemented. And you can also change it from there. But the compiler, it just takes the notebooks and it has some intelligence. So there's a specification of claimed 2-3 things you need to follow. And then the compiler automatically can create the components for you, in this case, Kubeflow pipeline components with the titles and description, inputs, outputs, and it also automatically learns which requirements your notebook has and does all the pip installs, and with those creates container image, publishes the container image, and also creates a KFP YAML file, and also can publish this YAML file to another location, for example, ML Exchange, or just put it on the Git repo. And with that, you then can just consume it as an ordinary Kubeflow pipeline component. In that moment, you don't even know and realize that the whole thing backing the component was a simple Jupyter notebook or Python script. We also put version information. So each time we change something, we put a version tag into the component. It's in the description as well. So you have a clear mapping between your versions. Also, the requirements are versioned. So for audit purposes, you can clearly make out which version of the component code and which version of the requirements have been used to create a certain model or data set. And then finally, Kubeflow will read that KFP YAML and send it over to Kubernetes, and Kubernetes pulls the image and executes it. That's basically how it works. We are, as I said, automatically pushing those images to image registry. So that's on the fly, and we also are taking the versions, and then you can just take it from there. And you can obviously also specify your own container registry if you like. So that means you even can, if you like, mix and match open source and closed source components if you think you want to use claimed in your environment and you have a couple of components you can't disclose in the community. You can also incorporate those and pull them just from your private registry, which obviously we don't want to encourage. We are in favor of like sharing everything with the community. In addition to components for KFP, as everything is now available as image anyway, we can also very easily push it to, for example, Knative or other serverless platforms. Here in this case, that's Code Engine, which is based on Knative. And also, for example, run it from the command line. You can execute a component from a shell script in a shell script, and you are guaranteed that all the requirements and everything is incorporated into the container. We also started to have automated testing for a set of components already, which are executed once you push to repository to make sure that the quality stays the same. The community is smaller than in Elira. It's a smaller project. We have here the members and contributors. And you also see we have, approaching 2,000 stars on GitHub already. And those are also there's also one IBM member. So Fake Karate Kid is the client, the University Hospital one. So then the question, why would we like to donate claim to the Linux Foundation? So to make it short, we had actually not a complaint, but a concern from the client using that library that it's a IBM repository. No, it was github.com/IBM/claimed. We fixed that. Now it's already in its own repository. It's github.com/claim-framework, but still it's not in open governance. And since it interacts with so many other projects which are already in LFAI, we thought it's just the perfect place to fit in. So the impact, as I said, we have this production use case of the University Hospital Basel. We are also using it in IBM Research platform. It's part of the Red Hat Open Data Hub. It's also open source. And it's currently evaluated by Novartis Research, and also Apple raised interest in using it, but they said they need the Airflow exporter production ready first, because they are on Airflow, not on Kubeflow. So what's coming next? So we want to, by end of this year, finalizing the specification version 1, so that we can stabilize it. Then everybody who wants to create components knows what 2 or 3 things he needs to implement in the notebooks. So it's basically the interface. No, for example, environment variables you are pulling for getting the parameters into your Kubeflow pipeline component, and also the requirements. And then the next thing is we are currently using ready-made Docker image. We also want to add the capability for those who know how to do it to override this Docker file and provide their own Docker file just in the notebook. Then we have a couple of existing components in the repository which are not following the specifications. So we need to fix those, that we can automatically create all of those. So we have 70 components, but I would say 50 of them compile, and 20 we have to bring to the latest specification. Then we want to push all those components then to MLX, to ml-exchange.org. And then we want to have more focus areas in the components itself. So at the moment, it's a lot of input-output databases, cloud object store, some TensorFlow models, some trusted AI models, or libraries are incorporated. But we want to also focus now on PyTorch, because PyTorch is moved in open governance. That's very interesting, promising. So we want to support it as well. We want to be better at Kserve. So we still have the state where KF serving was the thing to do. So we want to move over to Kserve. Knative is something which we have manually to implement the HTTP listener still. So we want to have a decorator. So it's prototype wise already running, which can encapsulate a component and just provide a HTTP API on top of it. So you can just push it to any Knative environment. We want to implement more on the trusted AI side. So art is lacking here, for example. And finally, we will also want to provide foundational models, which are in open source to be part of the library. Some of the community asked for supporting Julia as their main language to create components. And also from the R community, we heard that they would love to also use RStudio directly for creating those components, which is at the moment possible, but not as smooth as if you would use JupyterLab. So I want to finalize now with the formal request. The claimed authors hereby formally request the incubation of claimed as a sandbox project in LFAI and data. Thanks very much, and I'm open for questions.
And I think we just achieved quorum, so thank you, Alex, for joining. Do we have questions for Romeo? I have a question. Can you give us just at a high level what the implementation or what the use cases are that you've implemented this in your production solution that you've deployed it into?
Yeah, sure. So this is the university hospital created a model for estimating the volume of affected lung tissue of COVID-19 patients based on a couple of blood markers, and they achieved very good correlations. And that actually means you could just take a blood sample and you have a good estimate of the volume of affected lung tissue from COVID-19 before you send the patient to CT and get the data back and analyze the data. That is the use case. It's used in production in the sense of it's a research department of the University Hospital Basel which applies this, and doctors are allowed to have a look at the results of the algorithm, but they are not allowed to incorporate it into their diagnosis for legal reasons. So what they usually do, they have two systems, and one is the research one and one is the production one. So that's how far into production we got with it. And we published that, by the way. You can read that. It's on SciPy last year. I can also provide the link later. So this is basically the publication. You see also this image here, this heat map. And here, that's the pipeline. Maybe let's zoom in. The quality is not too good. So that's the pipeline now we built. In this version, it was still notebook based. And then we published it or pushed it to KFP for execution. And in the current state of the system, we can now directly use ready-made Kubeflow pipeline components. So most of those components, which are pure notebooks here in this scenario, are now available as KFP components, including their container images plus the pre-installed requirements available directly to be pulled into any KFP system.
Excellent. Yeah, drop that. Go ahead and drop that link in the chat. I'd like to read some more about that.
Okay.
Great.
So
with all of the focus on trusted AI and explainability, this is very helpful.
yeah, I will drop the Git repository also in the chat.
Excellent. Other questions for Romeo?
Sorry.
Go ahead, sorry.
I just wanted to mention here, this was now driven by the University Hospital researcher and not by myself, just to emphasize that adoption is already starting also.
It's amazing how many stars you have. 2,000 is a very large number.
That's true. Yeah, I have to be honest here. So the whole idea of claim started years before even Kubeflow existed. So this is a repository which so I'm a instructor for a couple of Coursera courses. We actually had the first AI course from a non research institution, and we started the repository there. And then we found out that, so we have now, I think, more than 1 million learners covered. And for the learning purposes, we just found out it's very, very helpful if we have coarse-grained components for teaching. No, that's where everything started. And starting from there, we created more and more and more. And then they were all in their course folders, and then we thought, no, it's actually something we need to merge, because it's useful for the courses, but also for production, because we put so much effort in making that stuff simple, stable, reusable, and that's the history basically of Claim. So it was kind of invented before Kubeflow and Elira existed, but now with Kubeflow and Elira in place, it's just making sense, and MLX and trusted AI libraries, everything now comes together nicely.
There are other projects in the foundation that are around education-based packages that people can just use and teach within their own universities, and they probably would be interested in some of this work as well.
Okay, I guess you are talking about the, I saw it today. I was also in contact with those folks. Let me double check. It's the OpenDS for all, I guess, no?
Yes, that would
Yeah.
be it. Yeah.
Yeah.
I bet. Yeah, it's a good contact for you.
Okay, I think I have to just redo the contact. It was like 2-3 years ago, but now it makes more sense now to get back to them again.
I would have a question for Romeo.
Yeah, please go ahead.
I quickly scrolled through the README file of your repository and I noticed the section related work. And could you please maybe say a few things how the project relates to the other projects? I mean,
Okay,
what are the big differences?
Share it. Okay, so let's open those two. So actually that related work, the pointer I got from Luciano Recenche, who was actually the brain behind Elira. So we just found out that Plumber and Orchest are doing similar things than Elira. And we have already had a look at it, but finally we thought it's it's not in open governance, no, that one here, and the other one I'm not 100% sure. So this one here is not in open governance. It has a lot of overlaps with what we are creating, and the other one, it hasn't actually a IDE. So it's something we had a look. It's like 2 years ago, but we decided that it's not something we can reuse or integrate. I think the things I covered here, those tables here, the answer is not so good because honestly that paragraph didn't come from me. It came from Luciano, so I'm a little weak in the answer, but that's the actual research we have done. And those are really state-of-the-art systems, no? Slurm and SnakeMake and Nime and Galaxy, they are widely used in the community, and that's why that should be the list of related work, actually, no, to be honest.
Oh, okay. Thank you. Yeah, it looks great. Thank you very much.
Yeah, thank you.
As a complete tangent, you might look at the link I posted in the chat for Scratch, machinelearningforkids.co.uk. It's just yet another flow editor, but I thought it was something that I hadn't seen before and I thought was quite interesting. So.
Yeah, that I know, yeah. Yeah, that relates maybe a little to Node-RED, no? We have covered Node-RED here. So the reason, so initially, before Elira was born, I was a huge fan of Node-RED. For those who don't know, it's also a drag and drop editor. The problem with Node-RED is that the runtime is based on Node.js. So it's not a pluggable runtime, and Node.js is single-threaded. So you cannot really use it for big data use cases. And the other thing is it doesn't have data delivery guarantees. No, it might lose messages between the nodes in between. And those things they haven't implemented so far, although I've requested those years before. That's why I think the combination of Elira, claimed Kubeflow, MLX, and the libraries it incorporates is more powerful. So it brings what Node-RED could have brought, including scalability and data persistence guarantees.
Well, I think Nick's working on those things, Romeo, but the Scratch software was interesting because it kind of fits together like puzzle pieces. So it doesn't have a flow diagram. These things kind of snap together. And they, like I said, they've just had some success with it in the UK for this Machine Learning for Kids program.
Okay.
So it's just something I wanted to share that I think, may not be applicable to any of our needs. But if you want to teach your kids how to do machine learning, maybe Scratch is another way of doing it.
Okay. Now I definitely have a look. And if you say Nick is working on those things, I need to grab another virtual copy with Nick. By the way, Nick is the author of Node-RED So like the Luciano for Elira is Nick for Node-RED.
Thank you, David. That's a great suggestion. Do we have any more questions for Romeo? Okay, then. So the proposal, Romeo, can you go back to the proposal page in your slides? Yep. Okay, so the proposed resolution is that the project claimed be admitted as a, let me find my words here, as a new project into incubation at the sandbox level into the AI and Data Foundation. Can I get a first motion?
A first motion from me, Beat Büssen.
Okay, thank you. Can I get a second motion?
Yeah, Alex Heckenberger, Onyx.
Okay, thank you. All righty. Can all voting members who are in favor please come off of mute and say aye?
Aye.
Aye.
Are there any
Aye.
objections? Great, thank you so much. Are there any objections or abstains? Okay, the motion passes. Congratulations. Romeo, great presentation. Thank you for bringing this interesting project forward.
Thank you so much. I'm really happy, and I promise I'll do my best to make this project a success for the project itself and also the related projects which it connects to. Thank you so much.
Thank you. And having the connections is really helpful. So I appreciate that you're going to look into those other projects, because that's
Cool.
part of why we do this, is to collaborate. So
Okay, cool. Thank you.
thank you. I have one more. I'm going to go ahead and share my screen if that's okay.
Yeah, let me stop.
Screen two. We have one more vote to do, and this is the approval of the meeting minutes from the last meeting. So the proposed resolution is that the minutes of the November 3rd meeting of the TAC of the LFAI and Data Foundation are hereby approved. Can I get a first motion?
Alex Heckenberger.
Great, thank you. And can I get a second motion?
Michael Rooknock, yep.
Thank you, Michael. Okay. And can all voting members who are in favor please come off mute and say aye?
Aye.
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 Okay, thank you all. Are there any objections or abstains? Okay, thank you all. The motion has passed. We just have a few more things to talk about. Let me get down to the bottom of my slide deck here. Just a reminder, the upcoming TAC meetings, we have one on December 1st, a new project also coming into as a proposed sandbox project. And then we have 2 annual reviews lined up at the end of the year. And then we will skip the last Thursday of December and start again in January. And we have many more new projects coming and lots of annual reviews. So thank you all who have signed up to do annual reviews. If you haven't heard from me, don't panic. I will be getting to you soon. We just have a lot of opportunities and projects coming in, so I haven't scheduled too far out. But I will be asking for those who have projects that are being sponsored to do their annual review. So just watch for an email from me. If you have any topics or suggestions for future meetings, we're always open to special topics. So just feel free to send them to us. And we have a wonderful new project manager, Lucy, who is helping us become more organized. So Lucy will help us get this part of it organized too. And I do want to thank everyone who has provided special topics, because they're always very interesting to the community. Are there any other things anybody would like to bring up? All right, with that, I will give you back a few minutes. Congratulations again to Claimed and Romeo for successful entry. And here is meeting details. If you do want to just keep in touch, you can subscribe to the TAC group calendar, and I also post out on Slack, usually a day before for the upcoming meetings. I really want to thank everyone who attended, especially voting members. It really helps us get through to achieve our votes. So I want to thank everyone. I hope you all have a good rest of your day. Evening,
all.
night.
Bye-bye.
Thank you all.
Bye.
Thank you so much.
Bye. Thank you.